So in a previous video, we discussed Newton's first law of motion, which is that an object at rest will stay at rest, and an object in motion will stay in motion until another force acts upon it. In today's video, we will be going over Newton's second law of motion. Newton's second law of motion. This is commonly seen as the equation F is equal to m times a. The F stands for the force. One way to think of force is how hard an object hits something. M stands for mass, which is how heavy something is. And acceleration is the A. One way to think of acceleration is how fast something is moving. The heavier an object is, the more mass it has, the more force that object is going to have as well. Another way to look at this is if you increase the acceleration of an object, you are also going to increase the amount of force it has. Now you can do a couple of experiments with the second law of motion. Today we are going to be using the same amount of force and trying to move objects of different masses. Hopefully, by doing so, the objects will travel different distances and potentially different speeds. Today, we have two different kinds of balls. We have a baseball and a tennis ball. We're going to be setting them up one by one, and Ethan is going to hit them as hard as he can with a plastic bat. As I said, he's going to swing the bat as hard as he can each time. This should keep the amount of force roughly the same. Once both balls have been hit, we will see how far they travel. Ready? We're going to hit the tennis ball now. Go ahead. Wow. So, you know what? Let's go see how far each one traveled. So here is the baseball. And then the tennis ball. Made it all the way over here. So why do you think the tennis ball went farther than the baseball?
Because the tennis ball doesn't get carried by the wind and it's hollow.
It's hollow.
Inside.
Okay.
Because the baseball is heavier, but it has stuff inside, so it's going to slow down.
Now, based off of just holding the two different balls, we can tell that the baseball is heavier, so it has more mass, and the tennis ball is the lighter of the two, meaning it has less mass. Now, for the purposes of demonstration, we're just going to assign the two a number. We're going to give the baseball a 4. We're not going to say whether it's 4 pounds or 4 grams because I'm actually not weighing these. I'm just assigning a larger number to the baseball and a smaller number to the tennis ball. Now, in order to use the numbers I assigned to the balls, we're going to change up this equation a little bit. We are going to divide each side by the mass. Doing so allows us to remove the mass from the right side of the equation, and we are then left with the force of an object divided by its mass is equal to its acceleration. Now, in this particular instance, the acceleration of the object is actually going to be the distance it traveled. We will need a force. This is the force that Ethan hit the ball with. I just assigned it 24. No real reason. Again, I don't have a way to actually measure the amount of force he used. So the force, 24, and we are going to first divide it by the mass of the baseball, which we decided earlier was going to be 4. which means that the acceleration or distance of the baseball is going to be 6. Now we're going to do that again, except this time we're going to use the mass of the tennis ball, which is 3, leaving us with an acceleration of 8. This matches with what we saw outside. The tennis ball did travel farther than the baseball did. Now it's up to you guys to come up with an experiment of your own that you can safely do using Newton's second law of motion. Have fun, everybody!